Okay, so let's take a look. So we've got a resistance here, value of 30 ohms, and we've got a inductive reactance value of 40 ohms. So we draw our triangles to help us to understand that. And as we can see here, we've got these two values, so we can go ahead and find Z, or total impedance in the circuit. So Z would equal XL squared plus R squared, square root of that. Yeah, 40 squared plus 30 squared square root. So I end up with 50, and that should be no surprise, 345, right? Okay, so I got a total impedance in the circuit of 50 ohms. And we know I'll scroll up here, we know we have a voltage of 240 volts. We know our impedance. So if we have our impedance, we can find our total value of current in the circuit. So my IT would equal my ET over my Z. And so it's 240 over 50 ohms, and that'll give me 4.8 amps. All right, so far so good. Okay, we have our resistance, we have our current, we can find our voltage value of voltage drops just using Ohm's law equals I times R. So 4.8 times 30 ohms, I get 144 volts here. And I can also place that on my resistor line over here. I'm going to put that right there, 144. And then for my inductor is my IL, so my amperage through the inductor times my reactance, and doing that, I get 192 volts. Put that there. All right, so let's find some powers. So remember that true power is when I have my voltage and my current in phase with each other, or in other words, a purely resistive circuit, or a purely resistive component within the circuit. And, just using Ohm's law, I can say, well, P, true power, P, equals E times I. So I got 144 times 4.8 amps, gives me 691.2. And because it's true power, it's watts. And then we can look at our reactive power, and our reactive power would be our voltage across the inductor times my amperage through the inductor. So I've got 192 times 4.8 gives me 921.6. And this is reactive power, so it's volt amps reactive, or VARs, 921.6 VARs. There's my reactive power. I put that here. And my true power, which is 691.2 watts. If you have questions as I'm going, I am keeping an eye on my secondary computer. So if you have any questions, just shoot them in. I'm happy to take questions while I'm lecturing. That's not a problem. Okay, so now that we have those two values, we can find our apparent power in volt amps. My apparent power is going to be square root of my true power squared plus my reactive power squared. So 691.2 squared plus 921.6. I get 1152 volt amp, 1152 VA. So let's take a look at our powers. And I've also asked for your for the inductor. We'll do that in a minute. So the value of inductance, or L. So we still need to find our power factor. I can put my apparent power in there, which is 1152. So we still need to find our phase angle and our power factor. And our phase angle and our power factor we can find out by putting our true power over our apparent power. So remember our our power factor is equal to my true power over the apparent power. So 691.2 over 1152. I get 0.6 times 100. So I get 60% power factor. And we can find our phase angle as well. So if we go our power factor over apparent power, our true power over our apparent power. So if we do that, we do the arc cos of that. Cos -1, true power over apparent power. We will get 53.1 degrees, 53.13, I believe. 53 degrees. Okay, the last thing I wanted you to do was to find the inductance. And if you recall, I said to you that the value of inductance is equal to the reactance over 2 pi frequency. So using that formula, right? That's just transposed. That's just XL equals 2 pi FL, right? I mean, that's all that is, 2 pi FL. So just transposed, I get the inductance equal to the reactance over 2 pi FL. So I punch those numbers in. I've got 0.106 henries, or right, it is 106 millihenries. All right, so that was your homework.